All right, today we're diving into something, well, pretty wild. It's a brand new idea in physics, a single framework that says it can solve not one, not two, but the three biggest mysteries in all of cosmology. That is a huge claim, so let's get right into it.
And it all kicks off with this really provocative question. What if all of cosmology's greatest mysteries are actually the same mystery? What if physicists have been chasing three different ghosts, when really they're all just shadows of one single thing?
And just to put the scale of this problem into perspective, look at this. Everything we know, everything we can see, you, me, the stars, the galaxies, all of it is just 5% of what's out there. The other 95%, we have basically no clue. It's this enormous cosmic mystery split into these two things we call dark matter and dark energy. Okay, so let's do a super quick rundown of these three dark problems. These are the cold cases that have kept physicists up at night for decades.
First, you've got dark matter. The story is simple. We look at galaxies, and they're spinning way too fast. They should just fly apart. So there must be some extra invisible stuff holding them together with its gravity. The go-to theory has always been that it's some undiscovered particle. The only problem? We've been looking for it for 50 years. We've built these incredibly sensitive detectors, and we have found zip, nada, nothing. Then, in the late 90s, we got another shock. Not only is the universe expanding, but it's speeding up. Something is acting like a kind of anti-gravity, pushing everything apart. We gave it a name, dark energy, slapped a placeholder on it in our equations called the cosmological constant, but let's be honest, we have no physical idea what it actually is.
And that leads us to maybe the most embarrassing problem in all of science. It's called the vacuum catastrophe, and for good reason. See, our best theory of how the universe works, quantum field theory, predicts that empty space, the vacuum, should be absolutely fizzing with a mind-boggling amount of energy. But when we actually go out and measure the energy of empty space, it's tiny. It's almost zero. It's not just a little off. It's the worst prediction in the history of physics.
And I want you to really look at this number. The theory says the energy should be x, and what we observe is y. The difference between them, it's a 1 with 120 zeros after it. I mean, we can't even comprehend a number that big. This isn't just rounding error. This is a sign that we are fundamentally missing something huge about how reality works.
So, how on earth could one single idea fix all three of these massive problems? Well, this new framework says we've been missing a key ingredient, something physics has always taken for granted and just ignored.
And that missing ingredient is observers. Now, hang on, this isn't what you think. Observer here doesn't mean a person with a lab coat or even an alien. It's a much broader idea. It's any system that has some kind of recursive self-reference, a stable pattern that maintains itself over time. Think of a galaxy or even a star. The truly radical idea here is that these observers aren't just passive witnesses in the universe, they are fundamental to the universe even existing in a complex way.
So let's compare the old view to this new one. The standard picture is that space-time is all there is. It's the stage, and we're just actors on it. But this new framework says, no, reality has two layers. You've got space-time, which they call M4, but you've also got this other layer, a kind of informational reality, which they call M theta. And it's at the intersection of these two layers that observers, these stable patterns, actually create structure. They're not just on the stage, they're helping build the set.
Okay, that's the big idea. A two-layered reality of space-time plus information. So now, let's see how this one single concept can supposedly knock down all three of those dark problems like dominoes.
First up, dark matter. The theory says, stop looking for a particle. You're never going to find one. Why? Because dark matter isn't a thing. It's an effect. It's the gravitational shadow cast by a galaxy's own pattern, its coherence, its history, all rolled into one. It's the gravity of information itself.
And suddenly, a bunch of puzzles just click into place. You know that weird rule, the Tully-Fisher relation, where a galaxy's light is perfectly tied to its gravity? Well, of course it is. The matter is the pattern, and the pattern is causing the gravity. And what about the famous bullet cluster, that supposed smoking gun for particle dark matter? This framework explains it just as well. The gravitational lensing, the bending of light, followed the coherent, stable galaxies, not the chaotic, hot gas. The pattern is where the gravity is. Okay, so if dark matter is the gravitational effect of a stable pattern, then what's dark energy? Well, it's the cost of maintaining that pattern. Think of it as thermodynamic exhaust.
It's the price the universe pays for complexity.
You know how any complex machine, like a computer or an engine, produces waste heat just by running? This theory says the universe is the same. Building and maintaining stable, coherent things like galaxies, that's hard work. It generates entropy, which is a kind of disorder. And where does that entropy go? It gets dumped into space-time itself, pushing it apart. So dark energy isn't some mysterious force field that's always been there. It's the current rate of entropy being produced by all the structure in the universe, right now.
Which brings us back to that colossal screw-up, the vacuum catastrophe. This framework says, hold on, what if it's not a mistake at all? What if it's a giant, blinking neon sign pointing us to this deeper reality we've been missing?
The idea is that quantum field theory was right all along. The vacuum is filled with that immense energy. But, and this is the key, it's informational potential. It exists in that m-theta layer, not in our space-time. Think of it as a vast ocean of possibilities. What we see and measure in our universe is just a tiny, tiny fraction of that potential that has been actualized or crystallized into the stable patterns we call matter and galaxies. So that 10 to the 120 number, it's not an error. It's the ratio of what could be to what is.
Okay, this is a really elegant, beautiful story. But is it science? Any good theory needs to be testable. It needs to make predictions we can go out and check. And this one does. In fact, it not only predicts things about the cosmos, it makes the stunning claim that the evidence might already be sitting in a lab, hidden in plain sight.
So here's a brand new prediction you can go and test with a telescope. If dark matter and dark energy are just two sides of the same coin, coherence and its cost, then they should be connected. The theory predicts that where you find a lot of dark matter in dense galaxy clusters, the local expansion of space should actually be slower than average. And out in the great empty voids between galaxies where there's very little coherence, the expansion should be faster. The universe isn't expanding the same everywhere. It's lumpy.
But here's the real bombshell. The framework claims we don't even have to wait for those cosmic surveys. It says this fundamental connection between information and spacetime has already been measured. Remember those controversial experiments like the M drive that seemed to produce a tiny, unexplained thrust? The results that everyone dismissed as experimental error because they broke the known laws of physics? This theory says that wasn't error. That was it. And check this out. They call this the forced convergence. You can take the numbers from those weird lab experiments and calculate the force you should see based on this new theory. And you can do it from 3 totally different angles in physics, and they all land on the exact same number, around 30 micronewtons. And what was the weird, unexplained force everyone was measuring in the lab? You guessed it, around 30 micronewtons. That is one heck of a coincidence.
And this isn't just someone playing with equations to get the right answer. The calculation is locked in by some of the most fundamental numbers in the universe, constants that you absolutely cannot change. We're talking about the Boltzmann constant, the fine structure constant, and even pi. The math is forced. It suggests those weird lab results weren't just noise or mistakes. They were the first whispers of a new kind of physics, and we just didn't know how to listen.
So let's just step back for a second. What we have here is a single, cohesive idea that claims to explain the structure of galaxies, the expansion of the entire universe, the energy of empty space, and weird results from a tabletop experiment. That's a pretty big deal.
So, to recap, dark matter is the gravity of a pattern. Dark energy is the thermodynamic cost of having a pattern, and the vacuum catastrophe is just the difference between potential patterns and actual ones. It all seems to fit, and it leaves us with this one final, mind-bending question. What if reality isn't fundamentally made of just stuff? What if it's made of stuff and meaning?